Hello, this is a test of the LinuxCNC Pull Request number 2562 to use G38.3 in Qt autoprobe.ngc for checking probe status. First, I will explain the setup that I'll run prior to each of the 4 tests runs to compare the previous software with the proposed change. This is also a sample starting configuration that anyone who is using Qt Dragon client and a tool setter can use to set up initial conditions that will work with the Qt Autoprobe tool remap code. So the initial setup is to run the client, which I am doing with the debug flag on. Note that this client is Qt Dragon, not Qt Dragon HD. So first we home the machine, and notice that the homing position is off screen on the machine video camera. One of the things that's important here is to make sure that your tool table has the tool probe set up with a 0 offset. We're going to load the tool probe using the M61 Q1. This avoids using the probe routine but tells the software that this is the offset of the tool that is loaded. You can verify that that has had its effect by coming into the tool screen and seeing that it's highlighted. Now we're going to position manually, which you could do jogging, or I have loaded these coordinates into my script here. Position over the tool setter. Actually, I'm going to go to my safe height first, and then position over the tool setter. These locations are arbitrary to my machine. You would want it to do as you see in the video. You'll see it come into view and position itself over the tool setter probe. Now in Qt Dragon, you switch to the probe screen, and then there are multiple sub-screens within here. You use the probe type tool button to switch through to the one that says tool probe. This is where you can use these buttons to establish the multiple parameters. If you watch closely here, the parameter we're about to set is the probe height. This is likely to change because I do not have repeatable tool settings. We set that by using this probe Z tool setter height tool. That initiates the probe move. And indeed it did change the probe height slightly. Now we're going to rise back up to the safe travel location. And I'm going to go over to a target spot that I've arbitrarily set up with a little tiny X that's hopefully visible there in the video. That's what this command does. In your workflow, what we are doing now is setting your G54 coordinates. You can see here in the display I have the ABS coordinates displayed. Once you get to this point, you could then, again from the tool probe, use the second button down here, this probe Z height of material. So it has lifted back up off the target the amount of this parameter here, the Z clearance distance. And so in order to get the tip of my tool probe right at the point where I want to demonstrate, we are headed to, I'm going to lift up 1/10 of a millimeter and then go back down 10 millimeters. So we are now positioned right at or on the X. We're now going to set this point to our 0 point using the G10 L20 command. The L20 says use the current parameters. The P1 here says do this to the first coordinate system, which corresponds to G54 commands, and set this point to 0, 0, 0. So once I do that, over here in the display you'll see that the X coordinate for the G54 frame of reference will go to 0. Alright, This is the end of the setup. You could use this setup if you are not testing pull requests, and then proceed to use the Qt auto probe remap code or whatever you have written, and you should be able to flow from here. So in our first test, we're going to run the original code with no error condition. All these runs are going to do the same steps, but during the error conditions, we're going to notice a difference in behavior, and when we use the modified code, we're going to notice a difference in behavior during the no error condition. In order to be clear to ourselves, we're going to begin this. We're going to send ourselves a message into the status log. So this is the run where we are beginning the test with unmodified code and no error. You'll also see this show up on the operator display. It's also available here in the Qt interface under status. Here we can see the history of things that it has told us under our status, including how we just hit the probe of the tool setter and the probe of our material. I'm going to close this message here and go back to the main and go back to here. So this is the point where we're ready to do the issue the tool change. I'm going to issue the tool change command T2 M6. And it brings us up to the message dialog where we can hit OK once we have loaded the new tool. I'm going to be finger tightening these tools because we're not actually going to spin them, and it will just make things go faster. Alright, so once the tool is physically changed, we're going to tell it to go measure its offset. Now the unmodified code as of this moment only brings it back up to the Z safe height. It also displays the probe result. So this command will display into the log the current coordinate system, and since it's set to 1 as is visible here, that means we are in the default G54 system. And so now we will display the offset parameter. So the important thing to notice here is that the current Z offset here matches the probe result. And remember that we used a 0 probe tool, so the offset should be the original probe tool minus the probe result, which gives us this exact match here. We're going to notice a different behavior when we test the modified code, which is next. We're going to mark our log with the difference here. We're going to say with the end of this testing, this is the end of the test with the unmodified code and no error. In order to switch out the code, all we need to do is rename the NGC. So I'm going to rename the one that we currently have to be ngc.original. And then we'll move this pull request. We'll rename it to be the version that, the name that the interface is going to use, the remap name. Alright, so then we need to go back. I'm going to manually reload the probe tool and tell LinuxCNC to go back to probe number 1. I'm going to, as I said, we have changed the test code to the new version that's proposed in this pull request. begin test with the modified code and no error. I'm going to clear these messages now so it's clearer as these messages come up what's going on. I'm going to verify that what the current offset is. And now we're going to issue the tool change. Notice that I have put one message in the code, in the remap code, to ensure that we know that we are in fact running the remap, the pull request remap, not the original. Alright, so at the end of the proposed remap code, the behavior is pretty much the same, except that the probe result that's displayed here, I don't believe is correct. The current offset actually is, let me pull it up again. Is this number 103 is this number, but it says it said the probe result is 150. If you remember the last time we did this, these numbers matched, and now they no longer do. I think that's a mistake. I think that the person who wrote the code is adding the offset that was discovered to this parameter, and that's doubling up the difference. So this is the end of the second run. So we're going to now reset for the third run, which is with the unmodified code. I'm going to rename the current one back to the pull request version. And rename the original one back to the operating one. Oh right, we have to restart the client in the middle here because we have to set up the error condition. To simulate the error, I have to shut down the client, as I just said. To simulate the error, I have to shut down the client. And I have to go in to the ini file and set up a situation where the probe does not succeed. The easiest thing I found to do that is to simply change the target location in Versa Toolsetter so that this is the right spot. I'm going to change it to here, and that way the probe, the tool, when it drops down, will not go on the tool setter, and eventually it will exceed the max probe travel distance, and that will trigger the error. So I'm going to save this, and having to change the ini file is why we had to restart the client for the second round of tests. We're actually going to have to restart the client again because after the error I can't get it back to working the way it should. I'm sure there's some way to do that. Alright, so here we are. I'm going to repeat these initial setups. Alright, now that we've completed all the original setup, I'm going to again mark our log here with a message. We're going to begin test with the unmodified code, but now we have an error. Okay. The only thing we need to do here is perform the tool change. Okay, we're going to hit OK, and it's going to attempt to execute the tool change. But you'll notice that we're not over the tool setter. So once it begins the probe, it will find that it's gone 100 millimeters and can't find it. And so then we get the message, and it's pretty clear. It says the G38.2 move finished without making contact. Abort parameter is 3. This happens, I'm not sure whether you have to have debug on or not. I haven't really tested that, but I have debug on, and this is the message we get with the unmodified code. So I'm going to close this, and we're going to mark this as the end. So now we're setting up for our final test run, and I'm going to blow past the testing stuff in this video, the setup stuff. Okay, we're now ready to do the fourth and final test run. So I'm going to begin test with modified code with error. All right, and the only thing is to run the tool test, the tool change. And you will confirm again that this is the remap code that is running. Okay, we're going to see it attempt to do the tool change. 100 millimeters to go, and it stops. And you'll notice that it does not send the error code. We have no message here. No message here. We have no message in the status. So, in conclusion, I believe that what the developer did is the opposite of what they intended. By switching G38.2 to G38.3, they suppressed the error messages that we really would like to have. So while I'm very sympathetic to this, I would really recommend against it. I think the error handling, the positioning of it, is actually quite good, and I have used that in a pull request that I'm preparing to return the tool head back to its original point when the tool change was called. But this change to G38.2, I believe, is ill-advised. That's my opinion, and here's the test. All the best to everybody, and thank you for allowing me to present this to the community.